Hey everyone, welcome back. This lesson is about graphing trig functions. This is the first of two lessons about graphing. Um, did I say trig functions? I meant tangent functions. My bad. So we're graphing tangent functions, and this is the first out of two lessons about tangent. So we're looking at the unit circle. And if we remember, every point on the unit circle, right, is represented by a coordinate pair. Each coordinate pair, the x value is the cosine of the function, and then the y value is sine. How do we figure out tangent? Well, if you remember our quotient identity, tangent of x, or theta, equals sine x over cosine x. So if we can find the sine, which is the y value, and then the cosine, the x value, divide them, we'll find tangent. All right, so we're going to actually start this time at negative pi, which is over here. We're going to go this way. All right, so negative pi, sine, that's 0 over negative 1. And if you divide 0 over negative 1, that's 0. All right, and then over here, negative 3 pi over 4. Okay. Negative root 2 over 2 for both of them. Negative root 2 over 2 divided by negative root 2 over 2 is 1. And some of you may remember tangent of the 45s are 1 or negative 1. Over here, this is be negative 1 and 0. That's negative 1 over 0. Well, when you divide by 0, can you? Nope. So this is undefined. Okay, that's long. Usually I just write U and D. Pi over 3, which is over here, negative pi over 3. So 5 pi over 3, which is the same as negative pi over 3. This would be negative root 3 over 2 and half, which is negative root 3, which is approximately negative 1.732. Okay. Negative pi over 4, that's going to be negative root 2 over 2, and root 2 over 2, that is negative 1. 0 is 0 over 1, which is 0. Pi over 4, root 2 over 2. Again, and now I'm up here. That is going to be 1. And over here, root 3 over 2 and half is root 3 over 2. Is approximately 1.732. Pi over 2 is 1 over 0, which is undefined again. Wow, that's different. We haven't had that before in our any of our trig functions. 3 pi over 4, it's here. That's root 2 over 2, negative root 2 over 2. So it's going to be negative 1. Pi, so we did one full cycle. 0 over negative 1, which is 0. 5 pi over 4, negative root 2 over 2. Negative root 2 over 2. So you can see that we are starting to repeat. All right, so now that we found tangent, we're going to use this column to graph it horizontally. All right, so let's take this and put it over in an XY coordinate plane. Now, when I looked at this, I realized, ooh, I made a mistake. My bad. This should be negative 1.732, as we just found on the other page. This should be positive 1.732. We can see that between here and here are numbers, and then you have that undefined. So this is here, between the pi over 2 and negative pi over 2. So I think I'm going to graph that first. So that's different, right? We haven't done that. So what does that mean when it's undefined someplace? Can you guess? That's right. It is going to be a vertical asymptote. Okay. So let's go over here. So I have negative pi. Let's come here. 1. I have 0, and then we went to 1, and then undefined. Negative pi over 3. So where is that? Well, remember this is 90, and this is 45. So it's actually halfway in between is negative 60. So it's negative 1.7. So it's not quite 2, so it's going to be right about here. Pi over 4 is negative 1. This is 0. This is going to be 1. Pi over 3, again, it's halfway in between. Not quite. Okay. 3 pi over 4 is negative 1. This is going to be 0 and 1. All right, so let me look. Well, that's kind of weird. Kind of looks like a straight line, but it is not. What happens, if you remember, when we're going to an asymptote, it's going to go and approach it as it goes towards infinity. So a tangent of a number can be actually really high. So remember, pi over 2 is 90. So if you type in your calculator, tangent of 89, what you get? Try then tangent of 89.9, tangent of 89.99999. Huge number. So it's getting really big. Super, super big. Same thing if you type in negative 89.99999. So, and we can see the asymptotes are here at the half, pi is over half. So over here will be our next asymptote, knowing our pattern. And then over here would be our next one. Here. So our key point, hold on, let me graph that. So here I'm graphing 3 cycles. And if you want to graph more, you can. So it's going to be at 0, 1, and it goes up. So if we're looking, so let's take a moment and really kind of bisect this. We have our asymptotes here, halfway between the asymptotes. So there's 1, 2, 3 lines, right? Halfway in between is 0, 0, right? So that's going to be where our x-intercepts are, which, you know what, since I'm here, I'm going to write x-intercepts. So we can write that later. Okay. And then at the fourth, pi over 4, so to the right of this x-intercept, it's up 1. To the left, it's negative 1. So we have that. Here's your x-intercept, it's up 1. Here to the left, it's down, and to the right, it's up. And so for one cycle, one period, you can see there's 3 key points. And then this is one period. Is here. One cycle. So what's the length of that? Well, we have negative pi over 2 to pi over 2, which is pi. And I know I'm doing them all kinds of, not the normal order. Amplitude is 1. Amplitude is 1 because, again, these key points are at 1 and negative 1. So that's a stretch of 1. Y-intercept, that's going to be 0, 0. Our range, which is nice, it's all real numbers, right? Because we're going all the way down to negative infinity and all the way up to positive infinity. Symmetry, we haven't done symmetry, but this one is odd. We talked about even and odd functions. We've also talked about identities, and this is odd. Tangent and sine are odd. So I've left domain, asymptote, and x-intercepts because these are a little bit more complicated. So I'm going to talk about the domain and the asymptote at the same time. So you can see that it's not all real numbers, clearly. And for this, I'm going to write it in set notation because it's easier than trying to do it in what is this called? Interval notation. So it's all real numbers except x can't be something. All right. So let's look over here about our asymptotes. And actually, I'm going to write our asymptotes down here because I have more space. So the asymptotes were negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2. Do you remember that? And then our next pattern would be 7 pi over 2, so 9 pi over 2. So what's the same? We have pi over 2 over each one, right? Okay. But then we also have this change. So an intercept, asymptotes are x equal. Vertical line, we know it's pi over 2. But we know there's some kind of change, right? Negative 3, negative 1, 1, 3, 5. And we've talked about this before, so we're going to multiply it by k. So that then is what? Well, negative 3, negative 1, 1, 3, 5, 7, 9, 11. What kind of numbers are those? Okay, so k is an element of odd integers. Now, if we remember, the relationship between asymptotes and domain is wherever the asymptote is equal to, right? This is equal to. That is where the domain is not equal to. So the not equal to over here is k pi over 2. And the k is going to be odd. K, the element of odd integers for both these k's. Right? All right, let's talk about the x-intercepts. Now you're like, okay, now I have x-intercepts, Miss Mendoza. Yep. They're going on forever. Yeah. And we have pi for all of them. Yes, the 0 can be 0 times pi. So that is also a change. Yes, you're right. Totally is. Negative 2, negative 1, 0, 1, 2. Probably the next one is 3, right? Pi, 4 pi, 5 pi. So that is going up by 1, right? Which is integers. Now I've already used k, so I'm just going to pick another letter. I'm going to pick p. Why not? So for p then, that's an element of integers. Now if you don't want to write z, you can just write literally integers, and that's fine. So this one, a little bit more complicated with the x-intercept and the domain and the asymptote. And yes, you have to graph the asymptote every time. Okay. So here's our equations. And for our graphs today, we're not going to change the b. They're going to have the same parent, same period as the parent function, which is pi. Again, I'm going to say that one more time. Pi. I didn't highlight that. Pi, not 2 pi, pi, as we can see over here, right? Pi. But I wanted you to see the full equation, since it's similar to sine and cosine. Here's our b. So our a is our amplitude. Our h is our horizontal shift, which is inside the parentheses. Over here, it's multiplied. So we really like actually the top one better. Always factored form. And then the last one is k, which is outside the parentheses. Now let's talk about the period. For b, the period is pi divided by b. Still that pi, but this time, I mean, you're dividing by b here, right? That b is this b here. But it's pi. It's not 2 pi. For sine and cosine, it is 2 pi for its parent graph. So that's why we divided by 2 pi. But this is pi, so you have to remember it's pi. And this is not a sinusoidal graph. Tangent is not. It's not continuous. It's discontinuous. There's a break because of the asymptote, right? We lift our pencil up when we graph this. So we're not going to change the period again, but I just wanted you to let it sink in for our next lesson next time. All right, so let's graph. Yes, I'm going to graph the parent graph. It's so you can make sure you know it. And remember that our parent graph straddles the center, goes here and here. So half of it is to the right of the y-axis and half of it's to the left. And I know I'm going to graph 3 of them. You're just like, Miss Mendoza, I think I'm going to have to do 2. Yes, but it looks funny only having 2 for me. I like the symmetry of that, to have 3. All right. So let's look at our function. And if you want to do the ones on the outside, sure. I'm just going to save time and do the ones on the inside. But that's up to you. All right, so what's our amplitude? Number in front, our A is 3. It's going to be our stretch. Period is pi. Horizontal shift is 0. Vertical shift is 0. Okay. So what that multiplier does, literally multiplies our y values. So 0 times 3 is 0. But -1 times 3 is -3. So those are all going to go down here. And then here, the zeros are all going to stay 0. And what about this one? Well, 1 times 3 is, you're right, 3. It's going to stretch up. So what happens? So it's stretching higher. Stretching higher. So our beautiful curve in the center of our tangent is getting flatter. Give you a moment, and I will explain that. So in our original function, we have this nice curve in here. See this curve? It's not like this. Nope, nope. Nice curve. Smooth. But because we've stretched it by 3, to connect from here to here, do you see it becomes more straight between here and here. So you can see how they compare. And if we multiply instead of 3, if we multiply by 10 or 20, it becomes more of a straight line as we stretch up. So that's what the multiplier does. It just stretches it. And tangent only has 3 key points. So it's actually in many ways simpler graphing it than sine or cosine. Right? So I expect to see those nice 3 key points for each period. Right, next one. Yeah, still graphing the parent graph every time. I really enjoy it. And it just helps you practice, really know that. Okay, so these I'm just going to do 3. Okay. All right, so what do we see? G of x equals negative tangent x. Ooh, you know what I forgot? I forgot to name that. I did not label. Label. Good habits, good habits. Okay, better. Okay, where was I? G of x. Okay, so I see a negative in front. Bloop. So what's my amplitude? Negative or positive? You're right, positive. That negative does tell me it's going to reflect. My period is still pi, 0, 0. So what it's doing also, so you know, that you're also, it's a multiplier like the amplitude. You're multiplying by -1. So -1 times 1 is, -1 times -1 is +1. So another reason why it really shows you why it reflects, right? In that multiplication. 0 times -1, 0. 1 times -1. Oops. So you have that nice reflection. So that's going to happen to every point. So beautiful. Isn't that pretty? So it reflects over the X. It actually looks like X's, doesn't it? Or an hourglass. And if you look at it and really contemplate it, it also looks like it reflects over the y-axis as well. Again, it's that odd interesting shape that has for this. Okay. Odd symmetry. I know, tangent's just kind of cool. All right, next one. Bloop. Okay. Woo. So, yes, I'm doing it again. Parent graph. I know. I won't always do the parent graph. But if this is a new graph for you and you've never done it, and you just try to graph the given function, you may still not understand the key point or know what the shape is. So it's nice practice just to really get that shape memorized in your muscles, in your hand. All right, amplitude, number in front. So that's going to be 1. The period, still pi. Horizontal shift. So this number after the x, right, inside the parentheses, plus or minus, that is the horizontal shift, pi over 4. Now, because I put pi over 4, it's positive. Please remember, it's to the right. Some of you are getting confused and going to the left. This is to the right. Vertical shift is 1, and that's going to be up. All right, because it is going to be a vertical shift up, I'm going to put our new midline. That always helps me. All right, and now I'm going to do our shift. Now we're shifting it to the right. Now, do we also move the asymptotes? Yes. Yes, we do. And I'm actually going to move them in a different color. All right, so that means they are moving pi over 4. So the distance for each line is pi over 4. So we're moving it 1 to the right. Now remember that center line still has to be between here, that center point. It's going to be on the midline. So it's going to be here. All right. And we're not reflecting, so we're going to go up 1 and down 1. Okay. So this point went 1 to the right and up 1. If you know this is the center, you know this one has to be up and this has to be down. That is our key point. So more than one way to graph. Moving all the points 1 to the right and 1 up. Or just knowing the shape and knowing that midline here and knowing that this one's the one to the right is up and the one to the right is down. So more than one way to graph. Label K of X. Fun. Look at all those colors. All right. Ooh, look at that. Okay. This one I'm not going to do a parent graph because there's a lot of things going on. There's actually 4 different things. So that can be a lot. So we have this. So I know it's going to reflect. I know my amplitude's a half. Period still pi. This is a horizontal shift. So we're going to the left. And -3, I'm going down. Okay. So I chose to do a horizontal shift that is not a multiple of 4. Or 2. So I wanted to do 6 because people have had questions about this. So whatever your shift is, this is what you want your lines to be. It's with that denominator. Now, if we're just doing pi over 6, and I'm going to just write it out. I'm not going to simplify it. So this is 2 pi over 6. This is 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. Do you see the pattern? Now, you're right. I could simplify this. This is pi over 3. This is pi over 2, which is an important number when we do parent graphs. and 3 pi over 6, sorry, 2 pi over 3, and this is going to be pi. So I'm going to use a simplified form on this side so you can see the difference between the two. Okay, I'm not going to draw a parent graph, but I'm going to put in some lines to help us to know where the original was and how we shifted it. So in the original parent function, our asymptote would be pi over 2, right? So that's here, pi over 2. All right. So how many lines is that? 1, 2, 3, 4, 5, 6. All right. And then this is our center. Would you agree? So every 6 would be a new asymptote. So 1, 2, 3, 4, 5, 6 would be over here. Right? Right. 1, 2, 3. So that's our center. The pi, correct. 1, 2, 3, 4, 5, 6. Okay. That would have been for a parent graph. But we are shifting over to the left pi over 6. So we're moving all those lines. So we would have had that center line, or that center point in between your two asymptotes would have been here, right? So now we're shifting to pi over 6. Gonna do that in green. Orange. So we're moving all these lines, right? Pi over 6. So this moved that way, this moved that way, and that way, and here. Okay. So now our center would be here. Now, I know I haven't shifted it yet, but there we are. Does that make sense? Okay, now I'm going to drop it. So you're going to say, well, Miss Mendoza, how do we reflect it? So what happens is I'll do some more little dots. When we would have done a regular graph, it would have gone up this way, right? But we're reflecting it down. So you would actually have done the reflection first. And so, I'm going to do this 1, 2, 3. The reason why I'm keeping it and not doing it in halves, because I'm going to have to drop it by 3. So the halves would have made it really long down here. So what we do in order, there's actually an order of operations. You would do the horizontal shift, you would do the amplitude, and then you would do the reflection, and then you would drop it down. So the reflection, it should be up here and up here. But when you reflect it, it would go up here and here. Now you're saying, why is it kind of in the middle of this square? The reason why, because it has to be halfway, right, between this. So there's 3, 1, 2, 3. Halfway would be about here. And half is there, right? So that's what the half would look like. But then I'm dropping it by 3. So I'm going to make a new midline right here. So these points here, I'm dropping it by 3. This orange is now down here and here. Okay, so reflection first, then vertical shift. So again, we're doing this and we're dropping it by 3. So it would be 1, 2, 3, or when you think of it, it's halfway through and again, half up. So here it's going to be half down, or up, here, okay, half up, okay. And when you do it, these should be on the same level. They shouldn't be higher or lower than each other. Okay. All right, and now I'm going to connect them. Start this way and you go here. So it's flattening it out. Like, ooh, yeah. Remember? That's what a fraction does. That's in front when you're multiplying it. It makes it more squat looking, more compressed. And we've shifted the scale on the x-axis, so it's more spread out normally. So usually there's 4 between here and here, 4 lines, 4 parts, but this is now 6. So we stretched it out even more because of our change. So hopefully that explained well how do you change it if it's pi over 6 or pi over 3, right? Yeah, order of operations, one more time. Horizontal shift, amplitude, reflection, then vertical shift. Okay, so practice on your own. For A and B, I chose only 2 transformations for each one, so they're a little simpler equations. Also, don't forget to scale, right? Your x-axis and your y-axis. Some of you are still not doing that. Please, good habits. Practice good habits. All right? Thank you so much for watching. Bye.